Hello everyone. So welcome back to the channel, and this is another video. So first, I will say bring your coffee. This is a very exciting project. We are building a project called zk-Ballot. And what is zk-Ballot? Zk-Ballot is decentralized voting system built entirely on a blockchain using zero knowledge proof. Well, we know in a world where trust in election is a more critical than ever, so this project is designed to guarantee privacy, transparency, and verifiability at the same time. And imagine a system where no one can see who you voted for, but everyone can cryptographically verify that your vote was counted without exposing your identity. And that's using that's the power of zk-SNARK, and that's what we're building today. But this is just a theory to get hand-on experience with entire smart contract development life cycle. You will learn on much things: design smart contracts, write, test, deploy, verify, and then interact them to via Block Explorer. So this is a project perfect for anyone interested in zero knowledge proof and smart contracts and building secure blockchain application from scratch. So grab your keyword, your coffee. This is going to be a fun educational ride into decentralized voting. And but first, I'm creating a slide. I'm summarize everything about zk-Ballot and how they work, key features, and many things. So bring your coffee and let's go. We talked previously about how zk-Ballot work and what is it. So let's enter this again. So it's a decentralized electronic voting system built on blockchain and powered zero knowledge proof. It ensures voter autonomy, election integrity, tamper resistance. The goal is to build transparent, secure, and trustworthy voting process that eliminate voter coercion and prevent double voting, resist manipulation and fraud. And the core principle is the voter can prove they voted correctly without ever relying on who they voted for. And uh, yeah, this is achieved using zk-SNARK, which allow private verification for vote validity. And we are solving a 5 key challenge in this project. The first key features is autonomy. Uh, what is mean by autonomy is the autonomy through zk proof, and the voter submit a zero knowledge proof that prove they are eligible and have a vote without revealing who they voted for. And any key feature I share some function implemented of each to see the example how they work. And the next is verifiability. Uh, Verifiability is mean by letting anyone check results. So it's every vote is equal transparency. Anyone check that votes were counted correctly, and user can verify the number of votes each option received without knowing who cast them. And integrity, once a vote is cast, it's immutable and cannot be changed. So this is by preventing tampering, and by making the address as a voted, it's preventing duplicate voting and enforces a vote finality. And the next feature is transparency. zk-Ballot provide transparent result without compromising voter privacy through on-chain logs, and events are emitted and for every vote, and optional to include them for auditing and propose, and the results are publicly queryable through votes or get results function. And the last is accessibility. So the system is deployed on zk-SNARK era. It is built on zk-SNARK and offer low gas fees and a fast finality, allowing mobile and the lightweight users to vote on easily. So it's deployed on A2 network, and the most known platform for it is zk-SNARK. You can use any other platform you're familiar with it, but I love zk-SNARK and I'm familiar more with it. You can use Optimism and Arbitrum or Polygon, and so I think now to let's speak about zk-Ballot architecture. So this slide show how all components connect, and voter generated zk proof submit via UI or CDI, and the smart contracts on zk-SNARK verify everything. So no personal identity is exposed. Only valid proof are accepted, and votes are counted securely on chain. Everything fully verifiable child zk-SNARK Explorer. So we have many key components like voucher. It acts as a user, and the zk verifier. Uh, Actually, I made this process before using Circom, but I faced some problems, and Circom is off chain. Is built on off chain, and you will be connected in on chain and off chain. So and then I use Solidity because I faced some problems. I will go back to solve it later, and I will push it again. So UI or CLI or a wallet for users to interact with the system, and the zk-Ballot smart contract, and the result. Okay, let's back to the voter and define what is. This is a select a voting option, and it triggers the generation of zero knowledge proof of chain or via helper tools, and the goal is to prove vote validity without revealing the vote content. And I say before is zk verifier is used this on chain. I'm not using off chain like a Secom or I think Circom, Zocrats, I think they are using on these concepts. I think Zocrats, I think, yeah, their name. And yeah, I will show you Circom. Yeah, this is the Circom that can be used on ZK. Yeah, it's compiled Russian in Rust, and they have a different syntax, but it's not hard. It's easy to work with it. Jibs are facing some challenge during some new functional requirement that I can build. Okay, let's back, and we have a zk verifier, and as I built in on chain. This is ensured that each vote is legitimate, like comes from an eligible voter, and follow the rule without revealing a voter identity or a voter choice. The goal is enforce privacy and integrity by cryptographically verifying the proof inside the smart contract before counting the vote. And UI or CLI, anyone familiar with front end, you can do a front end stuff like this interface for users to interact with the system. So, and the zk-Ballot smart contract is to bridge user input to blockchain transaction. It helps submit a vote plus proof to the smart contract, and yeah. So, and the zk-SNARK L2 Explorer, and the results. The zk-SNARK Explorer is the blockchain explorer of zk-SNARK layer 2 network. It reflected all interaction and the logs emitted from the zk-Ballot contract, and the result is let anyone verify final utilize independently. So can be retrieved using a contract view function like get a result function. So I think yeah, I am not cover much more information about zk-SNARK and zero knowledge proof. Just I give you some basics on what is zk-SNARK. You can check it and or Google it. There are a hundred of research paper that explains the Snark in depth, many blogs, many YouTube tutorials. So what you will learn, this is project is like a smart contract lifecycle. You will be learn how to design, build, test, deploy, verify, interact, and you will be familiar with zk-SNARK, and you will be learn about L2 and understand how real use case of zk proof and governance. So I hope to find it valuable. And the part two is a coding section. And so I will say thanks for watching, and let's go to code. And don't forget your coffee. Thank you.